All right, good afternoon, everybody. And so just to recap where we were standing, we were talking about fundamental theorem, and the big connector was that the fundamental theorem of calculus marries the idea behind derivative with integrals, and specifically this concept that if we integrate a derivative, those will essentially take each other in their inverses. So what they do is they allow us to recognize that the integral of that derivative can give us a relationship of the original function. And if it's over a definite integral here, we're able to come up with an entire change of that particular thing. So while that existed, and we haven't exactly gotten to the point to where we've taken an antiderivative to undo the derivative, we do want to know that those are related to each other, and that the integral and the derivative are kind of the same. So finally, the other thing I wanted to point out is that the other aspect of this is that when we integrate a rate of change, then that will give us a net change. One thing to think about is that the idea is that an integral will undo a rate. So a rate of change, if it becomes undone, just becomes an of change. Or in this case, a total change of the thing we were looking at prior. So we take a look, and we've done these questions, and we've looked through these. Nothing too crazy here. Same exact stuff as we've been doing. We can look at this calculator question. If I get a chance in class, what we want to do is, this is very similar to other questions we've dealt with. We have water is pumped into a tank. Rate of R of t is equal to 30 times 1 minus e to the negative 0.16 t gallons per minute, where t is the number of minutes since the pump was turned on. Was turned on. That's cool. If the tank contained 800 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 20 minutes? So what we have to realize is we have a rate. So we want to know, and specifically we want to know how much is in the tank after 20 minutes, so we are looking for a final amount. Well, if we want a final amount, the way we find that is we use an initial amount, 800 gallons, plus an integral of our R of t function. We just have to decide from what times. And if the tank was on for 20 minutes, we simply use the fact that this goes from 0 to 20, and that would give us our final amount. We would type that into our calculator, and if I recall, I'm just remembering this off the top of my head, I believe the answer is 1,220. We'll talk about how to type that into the calculator at a later time. So then what we do is we have situations like this. And I will do, well, you can see that we've got answers on the bottom, so I will let you kind of play with these and look at the answers. And if you wind up looking through this and you are struggling, we can see how we can help ourselves. So basically, just so you can see the first example, I'm giving you that I know what the integral from 1 to 4 is. I'm giving that piece to you of f prime of x dx. That's 6.2. And I know that f of 1 is 3. Just find f of 4. Well, f of 4 from f of 1 to f of 4, I'm asking for the final. So f of 4 is simply our f of 1 plus the integral from 1 to 4 of f prime of x dx, or 3 plus 6.2, and you simply get 9.2. So this page is fairly straightforward when it comes to a lot of these. Please do pay attention, if you're trying these, to number 4, that I use the word area. In each of my classes, I tried to make sure that I was very specific about this. If I use the word area, that is different than integral. Areas can be negative, integrals have to stay positive. So then we look at this, and we've got the total change theorem, and some of it is also being able to interpret what it says in words. For instance, if I tell you that W of t is the rate at which the baby gains weight after birth, where W is measured in pounds per month and T is measured in months since the baby is born, interpret each of the following indicating the correct units. If we were to interpret integral from 0 to 1 Wt of dt equals negative 0.127, we want to actually incorporate a lot of things. First off, we know that we're dealing with the baby's weight from 0 to 1 year. because it's an integral, we know that the change of weight are from, I said 0 to 1 year, I meant 0 to 1 month, is, and this is pounds per month, is negative 0.127 pounds. We mentioned that it's a change. We mentioned the time frame that we're looking at, and we're mentioning and when we say the number, we're mentioning that. Now, other ways we could say it: the weight of the baby decreased. We can say the total net change in weight. There's lots of ways we can say it, but you'll notice that it always says what we're dealing with. It tells us a time that we're dealing with it, and it explains what the number is with a unit. Change in weight, by the way, this is actually pretty standard. Babies lose weight in the first month, so that would be a true statement. The next one, interpret from 0 to 12, we would say that the baby gained 9.7 pounds between 0 and 12 months. Again, of course, we expect a baby to gain weight. So, with that said, just be aware that tomorrow I'm going to ask you if any of those make sense, if either of these two are reasonable, and to ask you what does it mean if I ask for that 1 over 40 minus 0, integral 0 to 40 ft dt, what does that represent? And those are going to be things that I'm going to ask you to be able to do. If we can do that, we're also going to need to be able to make sense of some of these examples down here. If w prime of t is the rate of growth of a child in pounds per year, what does the integral from 0 to 10 w prime of t represent? Well, again, w prime is a rate of growth in pounds per year, so that would be a change in weight. How do I know it's a change? Because we're talking about an integral, and change in weight from 5 to 10 years. If oil leaks from a tank at a rate of Rs to T gallons per minute at time t, what does 0 to 20 Rs to T dt represent? What does that tell me? It is the change in amount of oil in gallons in the tank from 0 to 120 minutes. If we look at the next one, a honeybee population starts with 100 bees and increases at the rate of n prime of t bees per week. What does 100 plus? Well, that's kind of weird. I see a plus. So this 100 is an initial amount, and this is a change. So initial plus change equals our final. So this integral right here, this integral expression actually gives us the final number of bees from 0 to 15 weeks. Done. Nothing too crazy. Again, I'm not going to really go through with how I would, not going to type this into the calculator. We've kind of had an opportunity to see this, but I do want to show you how some of these setups work. So if I were to set up number 4, the rate at which water is being pumped into a tank is R of t, 20e to the 0.02 t, where t is minutes and RT is in gallons. One thing to make note of, and I'm just going to make this really quick, that into is important. They will sometimes say will be pumped out of, and you have to realize that the rate is actually giving you a negative number. So watch out for that. So it's being pumped into a tank at R sub t is equal to that function there. Approximately how many gallons of water have been pumped into the tank in the first 5 minutes. So one of the things I'm looking at is I'm looking at how many has been pumped into the tank. So if that's the case, I really just want to know the change in the tank. Well, if I only want the change in the tank, I don't need an initial or a final. I'm just asking how much have I thrown in, and that is your integral from 0 to, I believe it was the first 5 minutes, 5 of r of t dt. And if I were to do this in the calculator, I would be typing this into y1 and then using that to assist me. If I look at, do I have any other good ones? Let me see. No, I think I like 7, so let's go ahead and we're going to look at 7 and 8. I'm going to leave 5 and 6. 6 is pretty much like the problems we did today on Monday. So let's take a look at 7 here. A tree has been transplanted after t years of growing at a rate of 1 plus 1 over t plus 1 squared feet per year. After 2 years, it has reached a height of 5 feet. How tall is the tree when it's been transplanted? So what am I looking for? I'm really trying to find what on earth was the height at t equals 0. That's sounding a lot like an initial value. So I think about it. If I want an initial value, I need to take my final value and I need to subtract whatever growth we got. So to find the height at 0, I would really need to take the height at 2 years and subtract from that an integral from 0 to 2 of my 1 plus 1 over t plus 1 squared dt. And from here, we would realize that this can be written as 5 minus that same exact thing. This would be considered, this is a question that eventually we'll be able to do without a calculator. Right now, I'm just working on the conceptual part. So from here, I would be typing this into my calculator and getting a final answer in feet. So it's, again, it's not a terrible little setup. Change minus our final amount minus our change of growth. So we're looking at 8. A spherical tank contains a lot of water. At least it's a lot if I were drinking it. Of gallons and t equals 0 minutes. For the next 6 minutes, water flows out. There you go, folks. This is what I was talking about up top. You have outflow from the tank at a rate of 9 sine of the square root of t plus 1 gallons per minute. How many gallons of water are in the tank at the end of the 6 minutes? So what am I looking for? End of the 6 minutes. So I want a final value. So how do we get a final value? We take the final is the initial plus the change. So in this case, we want, to know, let's call it big G of 6. Gallons at 6 is going to equal the number of gallons we have at 0, but now we have to be careful. So it's normally plus, but remember that this is a outflow, so this is actually a negative integral from 0 to 6 of 9 sine square root of t plus 1 dt. So when we actually type this into our calculator, we're going to type into our calculator, and by the way, this is one that I wouldn't expect you to be able to do by hand. We would type this as 81.637 minus the integral from 0 to 6 of 9 sine of the square root of t plus 1 dt. And once we type that into our calculator, folks, again, the answer just falls out and life is good. You will notice there is one answer choice that is a growth choice, just to see if you're paying attention. And I would expect that on the AP test. To have one answer choice that would show you a growth, one answer choice where it's just going to be a very small number, probably this 36,606, because that's probably what this answer is right here. Obviously right answer 81.637 minus that, and then the fourth answer could possibly be someone leaving something out of their calculator, probably not a radian degree problem. That's all we've got, so I hope this video finds you in good time and that you've only got 15 minutes. Good luck on that that test that you took home. I hope that you do well on that. Like I said, my big things, if you want to try these other problems, great. You have a calculator at home, so please utilize it. Make sure to look at those teacher questions and the reasonableness about a teacher salary. And we will answer questions and work problems related to the first part of the fundamental theorem of calculus on Tuesday. Have a great day, folks.